Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session we have completed the basic maths, whatever the mathematical tools that are required for the physics. So we covered those topics in the basic maths into just 2 lectures. So today onwards we are going to start with the kinematics part. So where in kinematics first we are going to deal with motion in a straight line. So all the previous year questions and concepts and extra questions like which have the scope to ask in the competitive exams, so those all will cover it in the classes. So just you have to follow the classes, make the short notes and then revise. Okay, so this is the routine that you should follow, guys. Okay, so chalo, without wasting much time, so let's get into the today's topic. So where we are going to see just the basics. So the speed, distance, displacement, velocity, average speed, instantaneous velocity and instantaneous acceleration. So that's it. But we are going to solve numericals. So almost some 18 to 20 questions I involved in this PPT. So we have to solve the questions which are all the previous year questions. Okay, so let's understand the concept through the question. See, the speed and average speed or average velocity or distance, displacement, these definitions are easy, but the questions which are framed on these topics you should follow. Okay, so when you solve n number of questions, so then you'll get the idea to solve the questions properly. So understanding, guys? Chal. So let's start with, so first the basics. So the average velocity and average speed. So then before this, so let me add one slide here. So where, so let's write the distance and displacement, the distance and displacement. So you already know that. So the distance is the total path covered by the object, whereas the displacement is the shortest path, right? So for example, so if a person has to travel from A to C, so then A to B and B to C, so that's a distance, whereas directly this A to C, it is the displacement. So the displacement is the shortest path covered, right? So it's a shortest path covered. So this already you learned in the grade 9th itself, right? So whereas distance is a total path covered by the body. It's a total path covered by the body. So whereas the distance is a scalar quantity. You are aware of the physical quantities, right? Now, so what is scalar, what is vector? So the distance is a scalar quantity and then displacement is a vector quantity. Displacement is a vector quantity. Right? So chalo. So and then we already know that, so the distance will be greater than or equals to displacement. So in which case it will be equal? So whenever the body travels in the straight line, so if object is moving in the straight line, or if body travels in straight line, travels in straight line, so in that case, so the distance will be equals to displacement. So whereas in all the remaining cases, so the distance will be greater than the displacement, right? So this also you know. So and sometimes in the questions they'll ask like, so the distance to displacement ratio will always be greater than or equals to 1. So the distance, the numerical ratio of distance to the displacement, so will always be greater than or equals to 1, right? So just bring this displacement to this side. So distance by displacement will be greater than or equals to 1. So or you can also write displacement by distance ratio. So the numerical ratio of displacement by distance which is less than or equals to 1. So that also you can write, right? So and the units are, you know, the SI units we use to measure the distance and displacement. So either centimeter or meter or kilometer, whatever. Okay na? So the dimensions that are clear, understanding the basic part, everyone. Chalo. So let's move further. So any doubts related to this distance and displacement? So these all you learned in the grade 9th itself. So now the average speed and average velocity. So first, you guys know the speed formula, right? Speed is nothing but it's a distance covered by the object in the given time. So the distance per time, right? So whereas the velocity is a velocity, so it's a displacement by time. So these are just the basics. So just wait for 10 minutes, we'll solve the questions. So if you all know these concepts, just skip and go to the questions directly. Okay, chal. So the displacement by time. So here, so as distance is a scalar quantity, so the speed is also, it's a scalar quantity, whereas the velocity is a vector quantity, so which will have direction as well as magnitude, right? So and what are the units? So the units are either meter per second or kilometer per hour, either meter per second or kilometer per hour. So and you know the procedure how to convert the kilometer per hour to meter per second or meter per second to kilometer per hour. So right, so kilometer per hour to meter per second. So 1 kilometer is equals to 1000 meters. So 1 hour is equals to 3600 seconds. So then 5 by 18. So whenever you have to convert from kilometer per second to meter per second, kilometer per hour to meter per second, so multiply it by 5 by 18. So and vice versa. So if you have to convert meter per second to kilometer per hour, so then 18 by 5. Understanding? So this is just a basic thing. Now, so the average speed and average velocity. So what does it mean by average? Over a period of time. So if a body covers some distance in regular intervals, so then the average speed will be given by the total distance covered by the total time. Total distance covered by the total time. Total distance by total time. And then, so what is the average velocity? The average velocity of the body, it's a total displacement by total time. Total displacement by total time. So and the units are going to be same. So you can also write here average speed to the average velocity ratio will always be greater than or equals to 1. Understanding? Because distance to the displacement ratio is always greater than 1, right? Understanding? Clear? So and one more point you can include here. So the distance can be 0, but the displacement can be 0, but the distance can never be 0. So you can also include that point. Let's suppose a person starts from point A and he reaches point B, and again he returns to point A. Again he returns to point A. So in that case, what is the average? What is the displacement? So the displacement can be 0. The displacement, you can write this point also. So the displacement can be 0. Okay. So whereas the distance cannot be 0. So the distance can never be 0. So distance is always positive. So whereas, so this can be 0, positive or negative. So the displacement can also be negative, but the distance is always positive. Okay now, clear this part everyone? So now, so these are the just basic formulas of average speed and average velocity and speed and velocity. And how do we convert from kilometer per hour to meter per second? Multiply it by 5 by 18. So if you have to convert from meter per second to kilometer per hour, just reverse it, 18 by 5. So this basic information is clear everyone? Chalo. So let's start with the questions now. So this is the standard question. So chalo, so let's solve this question. Chalo. So a train travels from city A to city B with a constant speed of 40 meter per second. So and returns back to A with a constant speed of 60 meter per second. So find its average speed and average velocity. See here. So first a train starts from city A and then it moves to city B. So let the distance between these two cities, let it be x. So while going, let's consider, so the body is moving with a velocity v1. The train is moving with a velocity v1. So while returning, so the distance is going to be same. So it's maintaining different speed. So let the speed be v2. So here distance x, speed v1, so that the time let it be t1. So while returning, let the time be t2. Okay now. So now we know that from A to B, while it is going from A to B, so the distance is x, speed is v1 or velocity is v1 and time is t1. So from there, shall I write? So the total the speed v1 is equals to distance by time taken. Speed is equals to distance by time. So then the distance, the time t1 is equals to, from here, x by v1 shall I write? So let it be. So then while returning from B to A, so then the speed it's maintaining is v2. So the velocity is equals to, so the distance by time taken. So the time taken here it is t2. So from here the time taken t2 is equals to x by v2. So now we have to find what is average speed and average velocity. So shall I say the average velocity directly 0? Average velocity is going to be 0. Why? Because the initial and final positions are same. So the displacement is going to be 0. Yes or no? It's starting from city A and moving to city B, again returning to the city A. So the initial and final positions are same. So then the displacement is going to be 0. So then average velocity 0. So now the question is, how do we solve for the average speed? So the average speed is equals to total distance covered by the body by total time. So the total distance by total time. So here if you observe, so what's the total distance? See here. So while going it's covering x, while returning it's covering x. So the total distance is 2x. So and then time. So time t1 while going from A to B, and while returning it's taking time t2. So t1 plus t2. So now what I am doing is, so to get the simple formula, so 2x by, in place of t1 I am writing x by v1. So and then in place of t2 I am writing x by v2. Right? So now let's solve this one. So we have got the average speed. The average speed is equals to 2x by x by v1 plus x by v2. Yes, x by v1 plus x by v2. So now, so 2x by, I am taking x common, so 1 by v1 plus 1 by v2. So here x gets cancelled. So from here I can write, so 2 by, so here v1 v2 is the LCM, so we can write v1 plus v2. So send this v1 v2 upside. So 2 v1 v2 by v1 plus v2. So 2 v1 v2 by v1 plus v2. So this is a average speed. This is a average speed. Right? So now this formula you should remember. So whenever they say, so from one place to another place, if the body travels with some speed and while returning it's maintaining another speed, so then find the average speed if they say. See here. So while going from A to B it's maintaining v1 velocity. So while returning from B to A it's maintaining v2 velocity. So in this case, so to find the average speed, so the formula is going to be 2 v1 v2 by v1 plus v2. 2 v1 v2 by v1 plus v2. So remember this. So now solve the question. This is a general formula. So now they gave the value. See here, v1 40 centimeter, v2 60 centimeter. So now v1 is equals to 40 meter per second and v2 is equals to 60 meter per second. Now substitute the values. So the V average speed is equals to 2 into v1 40, v2 60 by v1 plus v2. So 40 plus 60. So then the V average is equals to, so 2 into 40 into 60 by 100. So then two zeros cancel. So the V average is equals to, so 2 4s are 8, 8 4s are, sorry, 8, 8 6 are 48. So the 48 meter per second is the final answer. Clear? So the 48 meter per second is the average speed and average velocity is 0. So the option C is the correct one. Hope you guys understood. Clear? Any doubt here? Chalo. So let's move further. So let's go for the next question. So which was asked in NEET 2019. So pause the video, try this question on your own. A person traveling in a straight line moves with a constant velocity v1 for a certain distance x and with constant velocity v2 for the next equal distance. So the average velocity v is given by the relation. So try to understand the question. A person traveling in a straight line moves with a constant velocity v1 for certain distance x. For some distance x, he is maintaining the velocity v1 and with a constant velocity v2 for the next equal distance. For the next equal distance means again some same x distance in the straight line, he is maintaining the velocity v2. So let this point be A, let this point be B. So now what is the average velocity? So first, what is the average velocity formula? The average velocity is equals to total displacement by total time. As the body is moving in the total straight line, so shall I write the displacement and distance both are equal? The displacement and distance both are equal. So now see here, so what is the total displacement of the body or total distance? So x plus x, body is covering x plus x distance by time. So here from here to here, A to C, let's suppose it is taking some time t1. Some C to B, it's taking some time t2 because it's maintaining different velocities, right? Time will obviously change, right? So now the time, let it be t1 plus t2. So in the numerator we already know that this is 2x by, so now how do you find the time t1? The simple logic already you got, right? So how do you write? So we know that from A to C the velocity v1 is equals to the distance covered is x, time taken is t1. So from there t1 is equals to what? In place of t1 we can write x by v1, x by v1. So plus similarly see here, so v2 is equals to x by t2, the distance by time. So here C to B, the distance is x, time taken is t2. So therefore x by t2. So same thing I am writing here, x by v2. So where we need t2, right? So t2 is equals to x by v2. So just interchange. So again the same thing previously whatever we got. So 2x by x by v1 plus x by v2. So the same thing we got here also. So that's why the v average in this particular case will be equals to, so x gets cancelled, we'll get 2v1 v2 by v1 plus v2. So 2v1 v2 by v1 plus v2. So understood this part? Again this is the formula you should remember for this kind of questions. Okay, so now see whether this is there in the options or not. See, I cannot see this one in the options. So then what we should do? So let's go for, so one more step ahead. So what we do is, let's write, bring this 2 to this side. So v average I am writing it as v. So v by 2 is equals to v1 v2 by v1 plus v2. So let's reverse terms. So the 2 by v is equals to v1 plus v2 by v1 v2. So now 2 by v is equals to, so write v1 by v1 v2. So v1 v1 cancel, and then v2 by v1 v2. So then v2 v2 cancel, 1 by v1. So therefore I can write 2 by v is equals to 1 by v1 plus 1 by v2. So this is a final answer. So 2 by v is equals to 1 by v1 plus 1 by v2. So depending on the options you should change your solution. Clear? So this we got. So from there, so just do some mathematical part, so to get the correct option. Understood? Clear everyone? Sure. So now, so the thing is, so write the shortcut from the previous two questions. So what results you should remember, guys? So whenever a object covers certain distance a to b, let's suppose, so with velocity v1, so while going, and then while returning it's maintaining velocity v2. So in this particular case, so the average speed, so in this particular case, so the average speed will be equals to 2v1 v2 by v1 plus v2, and average velocity in this particular case is 0. Average velocity in this case is 0 because body is returning to the original position, right? So whereas the case 2, if the body covers some equal distance, let's suppose some x distance in time t1, so with velocity v1, so again the next equal distance x distance with some other velocity v2, so then it will take some other time t2. So then in this particular case, so the average speed and then average velocity both will be equal because the body is moving in the straight line path, right? So the average speed and the average velocity both will be equal, which is equals to 2v1 v2 by v1 plus v2. So 2v1 v2 by v1 plus v2. So this is the part. Clear? Understood? Chalo. So if you remember the formulas, you can directly substitute the values. That's it. Okay, otherwise you have to go for the procedure, which is a time waste process. So now next question. A particle covers half of its total distance with speed v1 and the rest half with the speed v2. So the average speed during the journey. See here, a particle covers half of its distance, half of its total distance. So first let's consider the total distance as 2x. Now half the distance, let it be x, it covers with velocity v1. So and remaining half the distance, which is again x, so it covers with velocity v2. So then what is the average speed? So in this particular case we know already the average speed, so which is 2v1 v2 by v1 plus v2. So 2v1 v2 by v1 plus v2, option C. No need to think also, direct question. Done? Chal. Next. So the question number 4. So try guys, pause the video and try it on your own. A particle covers half of its journey with a constant speed v. Half the remaining part of the journey with constant speed 2v and rest of the journey with a constant speed 4v. So find its average speed during the entire journey. First understand the question. A particle covers half of its distance. First let the, this is total thing. Now in how many parts it's changing its velocity? See here, in the first covers first half its journey with constant speed v. So let the first half is this one. So here it's maintaining velocity v. Half the remaining part of the journey, in the remaining part again half it's covering with a constant velocity 2v, and then rest of the journey with a velocity 4v. Understanding? So total distance, in that first half it's maintaining velocity v, and then in the remaining half again half it's maintaining velocity 2v, and rest half it's maintaining velocity 4v. So that's the question, right? So now what I am doing is, let's consider so the total distance as 4x. Let the total distance x 4x, because I can write this as x 2x. So this total thing is 2x. So again this is x, this is x, because this is exactly half they said, right? Again in the half, again half is covering with 2v and remaining half is covering with 4v. So that's why, so total I am considering it as 4x, so that first half will be 2x, second half will be 2x. Again in the second half, two halves, x and x. Understood? So I can take total distance as x, but the fractions comes, this will become x by 2. Again this is x by 2 by 2, which is x by 4. This will become x by 4. So instead of fractions, let me take the plain figures. Clear? Chal. So let's move further. So now what they are saying, so the concept is simple now. So we have to find the average speed. You guys know the average speed formula. The average speed is equals to total distance by total time. Total distance by total time. So the total distance, what's the total distance here? So this is 2x, x, x. So 4x is the total distance. So now here's velocity is different, here velocity is different, here velocity is different. So that's why, so the body will take some time t1 here. So here it will take some t2. So here it will take some time t3. To cover this x distance, it takes t2. To cover this x distance, it takes t3. To cover this x distance, it takes t1. So now what are these t1, t2 values? So you know that the time is equals to, see, the simple logic, speed is equals to distance by time. So then from there, time is equals to distance by velocity. That's it. Time is equals to distance by velocity. What is distance? 2x. So by velocity, v. So here t2. So what is t2? Distance by velocity. Distance is x, velocity 2v. Here also. So time t3. So which is distance x by velocity 4v. So now simply write here t1 plus t2 plus t3. So the times are t1 plus t2 plus t3. So now substitute. So what are t1, t2, t3? So just substitute the values. So we get 4x by, so t1, in place of t1, let me write 2x by v. And then in place of x2, x by 2v. And then in place of t3, x by 4v. Clear? So then we can write, so 4x by, so here it is, 4v is a LCM. So then it comes out to be, so 2 times, so 2 into 2, 4x, plus it goes 2 times, so 2 into x, 2x, and then it goes 1 time, so 1 into x, x. So I guess, no, I guess I took the LCM wrong, wait a minute. So 1, 2, 4, right? So then 2, 1, 1, 2 times. So the LCM is, yeah, correct only, right? Yeah, fine. So 4v, my bad, just a minute guys. So 4v, so then this comes out to be, so this goes 4 times, not 2 times. So 4 times, 4 into 2, 8x, plus, so this goes 2 times, 2 times x, plus this goes 1 time, so 1 into x, x. So from here, so this 4v goes up, so I can write 16xv by, so here 10 plus 1, so 11x, x cancel. So the total speed will be 16v by 11. So 16 by 11 v, option D. Clear? Understanding the concepts? Chal. So let's move further. So the numerical ratio of displacement to the distance covered. So what they are asking? The displacement by distance. See, displacement either equals to the distance or less than the distance. So this will be always less than or equals to 1. So if they ask distance to the displacement ratio, it will be greater than 1. So this is always equal to or less than 1. They asked displacement to the distance. Displacement will always be less than or equals to distance. When it will be equal? Whenever the body travels in a straight line. Right? Simple question. So now what is the instantaneous velocity? Till now whatever we have seen is the average velocity over the period of time. If the body covers the distance from here to some other point, so then the speed that it maintained during its journey, it's called average speed or average velocity. So now how do you find the instantaneous velocity? We already discussed it in the basic maths. Instantaneous means at that particular time. Let's suppose, so the body at an instant it is here. So at that particular instant, what is the speed of the body or what is the velocity of the body? So that I should know. So how do we find? So wherever you have to find the velocity, just draw here, find the slope of the curve. Slope means just draw the tangent there. Okay. So or I can simply write, so the V instantaneous is equals to, so the ds by dt. So slope is nothing but, the slope is nothing but what? Differentiation. Already we discussed in the basic maths. The slope is nothing but the differentiation, the slope of the curve. So wherever at whatever the point you have to find the velocity, just draw a tangent there and find the slope. How do we find the slope? Let this let this tangent makes an angle θ1 with respect to the x-axis. Then slope formula is tan theta. So m is equals to tan θ1. Right. So slope is nothing but differentiation. Right. So that's why ds by dt. So the v instantaneous is ds by dt. That's it. So if you want to find at this is point P, let's suppose. So if you want to find at this point, so then this is theta 2. Okay, so understanding, guys? So the v instantaneous is nothing but the instantaneous velocity is nothing but, so it's a differentiation of the distance, or we can say the slope of ST curve. ST means displacement time curve, results in the instantaneous velocity. Instantaneous velocity. The slope of ST curve results in the instantaneous velocity. Okay, so and then, so at any point you can find it. So let's suppose if you want to find it point P, so it's going to be ds by dt. So some angle theta 1 is there. So or we can write, so the velocity at point P is equals to, so the ds by dt, which is equals to some tan theta 1. Find the slope at that point. So if you want to find at point Q, so then again the display ds by dt, so which is equals to the tan theta 2, the slope at that particular point. Okay, so now sir, where the speed is more, where the velocity is more, so that how can we calculate? So that we can understand while analyzing the graph. So though I'll tell now also, so just remember that part. See here, here the theta 1, this is theta 2. So as you go this side, so the theta value increasing, theta 2 here, theta 2 is greater than the theta 1. Theta 2 is greater than the theta 1. So therefore tan theta 2 is greater than the tan theta 1. Tan theta 2 greater than the tan theta 1. So therefore shall I say, so the velocity at P, tan theta 2 is nothing but velocity at Q, sorry. So velocity at Q will be greater than velocity at P. So just analyze the slope. Okay now. So this is a positive slope, theta 1, because it's an acute angle. Theta 2 is again acute angle. For acute angles, tan is going to be positive. So that's why slope is positive here. Slope is positive. So if the slope is positive, velocity is positive. So these two velocities are positive. And which one is greater? So wherever the slope is more, there the velocity is more. Here at Q, the slope is more. So that's why the velocity at Q is more than the velocity at P. Okay now. So that's why we can say the body is increasing its velocity. So here from this graph we can analyze that. So increasing velocity graph, this one. This one is a increasing velocity. Understanding? Clear this part, everyone? Chalo. So let's move further. So this is about the instantaneous velocity. Simply remember the formula. So let's take one question. So which is the previous year NEET question. Two cars P and Q start from the point at the same time in a straight line. So they are moving in a straight line and their positions are respectively. So car P ikadundi. So let's suppose car P is here. So let's suppose car Q is here. So the position of car P with respect to the time is given as AT plus BT square. And then, so the car Q has position, so FT minus T square, right? So then they are asking at what time do the cars have the same velocity? So at what time do the cars have the same velocity? So that means the hint that they gave it in the question is the velocity of car P will be equals to velocity of car Q, right? So how do you find the velocity of car P at particular time? So this is the displacement at that particular time. So this is the displacement of car Q at that particular time. So now I need the velocity of car P at that particular time. At that particular time means the instantaneous. So how do you find the instantaneous? So it's dxp by dt. It's a dxp by dt is equals to d by dt of, so I can write xq. So the displacement of car P, if you differentiate that, we'll get the velocity of car P at that particular time. And the displacement of car Q, if you differentiate that, we'll get the car Q velocity at that particular time. And they said they have the same velocity at that particular, at what particular time they have the same velocity. So that we are calculating the velocities and equating them. So because they said same velocity. So now the simple part. So the d by dt differentiation you already know, right? So d by dt of what is the displacement of car p? At plus bt square, which is equals to, so d by dt of, so xq. So what is the displacement of car q? Ft minus t square. Ft minus t square. So right, so then here we can write differentiation of this one. So which we can write, so differentiation of At is a, with respect to t you are differentiating. So a is the constant, dt by dt is 1 plus, so the differentiation of bt square, so which is nothing but 2bt, b comes out, t square differentiation is 2t. So then here this side, so ft minus t square, so the differentiation of ft is f minus, so the differentiation of t square is 2t. So we required at what time, so t we have to find. So then bring t terms to one side, remaining to the other side. So here I can write 2bt plus 2t, bring it to this side, and then this is f minus a, send this a to that side. So then I can write t common, so which comes out to be 2b plus 2 by f minus a. So then t is equals to f minus a by 2b plus 2, or you can take t is equals to f minus a by, if you take common 2, so b plus 1. So check the option. So a minus f, no. A plus f, no. A plus f, no. F minus a by 2 into 1 plus b or b plus 1, both are same. So option D is the correct one. Understood guys? Clear the concept? Sure. So next. So let's take the next question. See, pause the video. Whenever the question appears, you just pause the video and try it on your own. Okay. A particle moves along the straight line OX. So a particle moves along the straight line OX. At time t, the distance x in meters of the particle O is given by, so the some particular time, at some particular time, so let's suppose at this point, so the displacement of the particle is given by 40 plus 12t minus t cube, So then how long would the particle travel before coming to the rest? So see here, how long particle travels before coming to rest. So what is the hint given here guys? Before coming to rest, that means its velocity is becoming 0, right? Coming to rest, understand the hints given in the question. So if the body is coming to rest, so then its velocity should be equals to 0. That's it, right? So that's the hint you should catch. Now x is given. So then what is dx? Velocity, how do we find? So the velocity is equals to dx by dt. So d by dt of x. So what is x given? 40 plus 12t minus t cube. So then here we can write, so d by dt of 40, 0. So then 12t differentiation, 12 minus, so t cube differentiation, 3t square. So 3t square. So this is the velocity v given, right? So this velocity they are saying equals to 0. So then I can write 12 minus 3t square is equals to 0. So from here 3t square is equals to 12. So then 3t square is equals to, t square is equals to 12 by 3, 4. T square is equals to 4. From there t is equals to plus or minus 2. T is equals to plus or minus 2. So now what they are asking, they are not asking us the time. How long would the particle travel before coming to rest? So it comes to rest after 2 seconds. So till 2 seconds, how much distance it covers? So the distance function is given, which is 40 plus 12t minus t cube. So now the distance covered in t is equals to 2 seconds. In t is equals to 2 seconds. So which is time can't be negative, just take it as positive. So for 40, 12 in place of t, write 2 minus 2 whole cube. So then 40 plus 24 minus 8. So this is 64 minus 8, 56 meters. So this is 56 meters. Option C is the correct one, guys. Clear? Understood? Chalo. Next. So the question number 8. So the displacement time graph of a moving particle is shown below. So the instantaneous velocity of the particle is negative at the point. So the instantaneous velocity where it will be negative. See here. So there are 3 points given, C point, 4 points given, D point, E point, F point. So I'll tell you one simple trick. So draw the tangent. Draw a tangent. At whatever the point they asked us to find the velocity, so draw the tangent at that point. So they asked instantaneous velocity. This is x versus t, that is displacement versus time graph. See here, it can be given s, or it can give, they can give x. X is also displacement, s is also displacement. Fine. Now, so at C, draw the tangent. At D, draw the tangent. At E, draw the tangent. At F, draw the tangent. Okay. So now, see, with respect to positive x-axis, we have to measure the theta. So let this be angle theta 1. So here at point D, so the theta is directly, it seems to be 0. Right. So the theta is 0 means here at point D, the slope is 0. If the slope is 0, the velocity is 0 at that point. So then at point E, if you observe at point E, see here, so the angle is greater than, let it be theta 2. So the angle is greater than 90 degrees, and then here it is, let it be theta 3 at point F. Here it is theta 3, which is acute angle. So the theta 1, theta 3 are acute. These are at what points? Theta 1 for C and theta 3 for F point. Understand properly. At theta 1, if you draw the tangent, it's making an acute angle with respect to the x-axis. So at F point, again it's making the acute angle. But at point E, it's making the obtuse angle. The tangent is making obtuse angle with respect to the positive x-axis. So whenever thetas are acute, so you know that the tan theta value is going to be positive. Theta less than 90, tan will be positive, right? So tan of 90 minus theta, which will be positive value we get, right? So then, okay, so this is positive. So if the tan theta is positive, the slope is positive. If the slope is positive, so the instantaneous velocity will be positive. So then the instantaneous velocity is going to be positive. Clear? Sure. Next. So the next, at point E, so what we can write at point E, so the slope theta 3, it's theta 2, right? So theta 2, it is obtuse. So tan, which is greater than 90, for the angles greater than 90, it's going to be negative. So the tan, this is going to be negative for the obtuse angle. So if tan theta is negative, so the slope is negative. So if the slope is negative, then so the instantaneous velocity will be negative. So then the instantaneous velocity is going to be negative. Clear this part, everyone? Understood? So here what they asked in the question, so the displacement time of moving particle shown in the below. So the instantaneous velocity of the particle is negative at the point. At which point it is negative? At E point. So option C is the correct one. So the simple logic or trick shortcut you can remember, whenever the tangents are like this, if the tangents are like this, so they indicate positive slope. Okay, if the tangents are like this, they indicate negative slope. If the slope is negative, so for the displacement time graph, so the velocity is going to be negative, right? So simply if you draw the tangents, this is slant this side, but at E it's slant this side. So that's why the slope is negative at point E. You need not to go for this. Understanding? Clear this part? So whenever the tangents are like this, slope 0. So at point D, slope 0, velocity 0. Done? Chalo, let's move further. So now the average acceleration and the instantaneous acceleration. So you already know that the acceleration is equals to the rate at which the velocity of an object changes, right? So the acceleration is equals to, it's a change in velocity by time. It's a change in velocity by time. So v2 minus v1 by time taken. So whereas what is average acceleration? The average acceleration is equals to, so the total change in velocity, the total change in velocity by change in time. By change in time. This is over a period of time we write. So that's why it's going to be delta v, or else first write v2 minus v1 by t2 minus t1. So which is nothing but, so delta v by delta t. Delta v by delta t. So now, so what about instantaneous acceleration? The acceleration instantaneous is equals to, so the instantaneous, whenever I say, it's dv by dt. So the very small change in velocity at that particular time by that time, small time. Dt is a small time, dv by dt. Clear? So the instantaneous acceleration and average acceleration. So in the units you already know, it's meter per second square. So what if they ask you to write the dimensional formula for acceleration? What are the dimensions? Dimensions are also important. From now you should write the dimensions. See here. So previously I forgot to write for this. You just write down for the velocity. Where do we write? Where did we write? So yes. So for first slide low, in the first slide, so let's write for the dimensions of distance and displacement. What are the dimensions? The dimensions of distance and displacement. So they both are measured in some meters, right? So for meters, so it's going to be L. It's going to be L, right? Length. So whereas in the case of velocity, so what are the dimensions? The dimensions of speed or velocity, so which we can write it as, so distance L by t. L by t. So which is nothing but L t to the power minus 1. L t to the power minus 1. So for both, for speed and for velocity, for average speed or average velocity, the dimensions are going to be L t to the power minus 1. So the same thing will be for the instantaneous also. So instantaneous, if it is velocity, that's going to be same, the units, the dimensions. So here also you can write, so the dimensions are L t to the power minus 1. Understanding? Sure. Next. So now let's come to the acceleration part. So the acceleration dimension, see here. So the length L in meters is nothing but L by, so second square is nothing but t square. So then L t to the power minus 2 is the correct one. L t to the power minus 2. Clear? What is average acceleration, instantaneous acceleration, their formula, and we can write this one. So in the instantaneous acceleration, it's nothing but, so instant d by dt of v. What does that mean? So the differentiation of velocity gives the acceleration. So that means, so shall I say the slope of vt curve, the slope of vt curve will result in the instantaneous velocity. The slope of vt curve will result in the instantaneous velocity. This point is clear, everyone? The slope of vt curve results in the instantaneous velocity. Yes or no? D by dt of v. So the differentiation of velocity, differentiation means slope, slope of vt curve, slope of vt curve results in instantaneous velocity. Done, everyone? Now next. So the next one more thing, retardation. So what is retardation? So retardation is nothing but negative of the acceleration. Just remember this part. Retardation is the negative of acceleration. So whenever they ask you to find the retardation in the question, just mention First to find the acceleration and take the negative value of that acceleration. So that's it. No need to go for any further procedure. So what are the dimensions? So which has the same dimensions as of the acceleration. So what are the dimensions? L t to the power minus 2. Done? Clear? Understanding? Everyone? Let's take one question. Pause the video and try it on your own, guys. A particle is moving so that its displacement s is given. So some function. So its velocity at the instant when acceleration is 0. See here. So first the displacement function is given as t cube minus 6t square plus 3t plus 4. Let it be now. So its velocity, find the velocity when at an instant where acceleration is 0. First find the acceleration, equate it to 0. Okay, so that's the procedure you should follow. So now to find the acceleration, first we need to find the velocity. Yes or no? What is velocity? Which is ds by dt, which is nothing but d by dt of displacement. So what is displacement? T cube minus 6t square plus 3t plus 4. Alright. So then t cube, which is 3t square minus 6t square, which is 12t, so plus 3. So this is the velocity that we got, right? So then find the acceleration. The acceleration is equals to dv by dt, just now we have seen, so which is nothing but d by dt of 3t square minus 12t plus 3 plus 3. So then the differentiation of 3t square, which is equals to 3 into 2 6 and t to the power 1 is t. So and then minus 12t differentiation 12 and 3 differentiation 0. So therefore the acceleration we got. So then what they said? So when the acceleration is 0, they said acceleration is 0. So equate the acceleration to 0. 6t minus 12 is equals to 0. 6t is equals to 12. Then t is equals to 12 by 6, 2 seconds. So now at this time when acceleration is 0, what is the velocity? At this time, what is the velocity you should find? So how do you find the velocity? We know the velocity function as, what is the velocity function? 3t square minus 12t plus 3. So at what time we need? Acceleration is becoming 0 at t is equals to 2 seconds. At that time, what is the velocity? So 3 into 2 whole square minus 12 into 2 plus 3. So which comes out to be 4 into 3, 12. So this is 24 plus 3. Yes, 4, 3, 12, 24, 3. Yes, fine. So this is going to be 15 and then this is 15 minus 24 minus 9 meter per second. So minus 9 meter per second. Option D is the correct one. Understood? Clear, guys? Concept? Chal. Let's move for the next. So the question number 10. So what's the question says? The motion of a particle along the straight line described by the equation. So displacement of the particle is given 8 plus 12t minus t cube. So then where x is in meter and t is in second. So the retardation of the particle when its velocity is 0. So retardation means first find the acceleration. Acceleration when its velocity becomes 0. So when its velocity becomes 0. So first find what is velocity. So the velocity is equals to dx by dt. So which is nothing but d by dt of velocity function. Displacement function 8 plus 12t minus t cube. So then 8 differentiation 0, 12t differentiation 12, right? Minus, so this is 3t square. So this is the velocity. So then also find the acceleration. So they said when velocity becomes 0. So velocity is becoming 0 at what time? Let's see this one. So 3t square is equals to 12. So then t will be equals to plus or minus 2. So then t is equals to 2. At t is equals to 2 seconds, the velocity is becoming 0. So now at this point, we have to find the acceleration. What is acceleration function first? We have to differentiate the velocity to get the acceleration function. So d by dt of velocity. Velocity is 12 minus 3t square, right? So then 12 differentiation 0. So this is going to be minus 6t is the acceleration. So now find the acceleration at time when velocity becomes 0. Velocity is becoming 0 at t is equals to 2 seconds. So at that time, so let's find the acceleration. So minus 6, so t minus 2. So just 2, so this is going to be minus 12. So the acceleration is minus 12 meter per second square. So but we need what? The retardation. So the retardation is negative of the acceleration minus a. So which is minus of minus 12. So which is 12 meter per second square. This is going to be 12 meter per second square. The option D is the correct one. Understood, guys? Clear? Sure. So let's go for the question number 11. So the position vector of the particle is given. So this is caps, I guess. So this is 6t square minus 4t plus 6 I cap. So plus t square j cap. Find the velocity vector, speed of the particle and acceleration vector at t is equals to 3 seconds. So see here. So the position vector is given as t square minus 4t plus 6. So that's I cap. So that's printing is given wrong. So I cap in vectors. So I cap, j cap, k cap are the respective directions in x, y, z. So plus t square j cap. T square j cap. Fine. So find the velocity vector. So what is the velocity vector? So the velocity vector is equals to differentiate the position vector. This is a position vector. So then here position vector has x component and y component. So the position vector has x component. So therefore the x component of velocity will be the differentiation of the x component of position. So which by dt, and then vy is equals to dry by dt. So just differentiating the velocity vectors. See, we need velocity vector. So there is x term, there is y term. So first differentiate the x term with respect to time so that we get velocity in the x, and differentiate the y term with respect to time so that we get the velocity in y direction, right? So then vx is equals to d by dt of, so rx t square minus 4t plus 6. So then what is this we get? So this is 2t minus 4. So 2t minus 4. So this is a velocity in x direction, which is I. So 6 differentiation is 0, however. So then velocity in y direction, which is going to be d by dt of, so what is there in the ry position vector of y? So t square, so which is nothing but 2t. So let it be 2t j cap. So now the total velocity vector will be equals to vx I cap plus vy j cap. So this I cap j cap part we learn it in vectors in detail. Okay, hope you guys are already having basic idea about this. Okay, so then v is equals to, what is vx? 2t minus 4 I cap plus then vy, what is vy? 2t j cap. So then see here, they are asking what is velocity vector at time t is equals to 3 seconds. So the velocity vector at time t is equals to 3 seconds. So how do you find at time t is equals to 3 seconds? So just t in place of t substitute 3. So 2 into 3, 6 minus 4 I cap. So plus 2 into 3, 6 j cap. So therefore the velocity vector at time t is equals to 3 is equals to 2 I cap plus 6 j cap. 2 I cap plus 6 j cap. This is a velocity vector. So then they are asking us speed of the particle. So speed is nothing but magnitude of velocity. Speed is the magnitude of the velocity, which is magnitude formula is just square of the I cap, so square of the j cap coefficients, 2 square plus 6 square. So which is going to be 4 plus 24, so 36, so which is root 42. So root 40, 4 plus 36, so which is root 40. This is the speed, right? So then acceleration of the particle. So what is the here option should not be there because they asked us 3 questions, right? Find the velocity vector, speed of the particle and acceleration of the particle, acceleration of the vector at t is equals to 3 seconds. So just don't consider the options, guys. For this question there should not be any options. I guess the previous question options they kept it here directly, so some printing mistake. So don't take the options for this question. So just directly solve the question. So we got the speed, and can we find the acceleration vector? So how do you get the acceleration vector? So we got velocity vector as 2t minus 4 I cap plus 2t j cap. So then, so acceleration vector is nothing but, so differentiate the velocity vector. So then again the same thing. So the acceleration in the x will be equals to, so differentiate the velocity in the x, and then acceleration in the y, so which is differentiate the velocity in y by dt. So this is going to be d by dt of velocity in x, which is 2t minus 4. So then 4 differentiation 0, 2t differentiation 2. So this is a ax. So then ay, what is ay? Which is equals to d by dt of, so vy, so 2t. So what is 2t? So which is again 2, right? So 2 j cap. So then the acceleration vector is going to be ax I cap plus ay j cap. So what is ax? 2 I cap plus 2 j cap. That's it. So this is the acceleration vector. So the procedure is simple. Understand the procedure, guys. So the position vector is given. Then how do you find the velocity vector? Just differentiate the position vector. Position means it's a displacement. So displacement, if you differentiate, you will get the velocity. But the position is there in the x direction, it's there in the y direction. If the z is also there, find the velocity in z direction as well. So x direction we differentiated, t square minus 4t plus 6. So its differentiation is 2t minus 4. Here its differentiation is 2t. So the total velocity vector will be vx I cap, vy j cap. So that whole thing. So they asked us to find at t is equals to 3 seconds. So that's why I substituted t is equals to 3. So 2 into 3, 6 minus 4. So and 2 into 3, 6. So this is going to be 2 I cap plus 6 j cap. This is a velocity vector at time t is equals to 3 seconds. So then I need the speed, which is nothing but magnitude of velocity. So the magnitude is going to be square root of 2 square plus 6 square. This vector part you will understand when I deal motion in a plane vectors concept. Okay. So then find the velocity, root 40. So then acceleration, the same thing. Differentiate the velocity. So velocity is there in the x, velocity is there in the y direction. That's it. So therefore differentiate the x term, we get the acceleration in the x. Differentiate the y, so we get the acceleration in the y. So then the final acceleration will be ax I cap, ay j cap. Ax is this one, ay is this one. That's it. So this is going to be the final acceleration. So the acceleration at t is equals to 3 seconds they said, but there is no t term. So this is the final acceleration you can consider, because no need to substitute t. There is no t term in it. Done? Clear? So let's see the next question. So the x and y coordinates of the particle at any time x equals to 5t minus 2t square, y is equals to 10t. So then where x and y are in meters, t is in seconds. The acceleration of the particle at t is equals to 2 seconds. See here. So the x and y coordinates of the particles. So that means the position of body in x direction is given 5t minus 2t square. And then so the position of particle in y direction is given, so which is 10t. So first finally they are asking acceleration. So first can we find what is the velocity in x direction, which is nothing but dx by dt. So which is equals to d by dt of x. X is given as 5t minus tt square. So then its differentiation is going to be 5 minus 2 into 2, 40. So this is the velocity in x. So then can we find what is acceleration in x, which is differentiate the velocity in x direction with respect to time. So the d by dt in d by dt of vx. What is vx? 5 minus 40. So 5 differentiation is 0, and then minus 40 differentiation is minus 4. This is ax is minus 4. So let it be. So then what is this one? The velocity in y direction is going to be dy by dt. So which is velocity in y direction. So dy by dt, which is d by dt of 10t. So 10t differentiation is 10. This is vy. So now what is acceleration ay? Ay is equals to dvy by dt. So which is d by dt of, so vy is 10. So d by dt of 10 is 0. So this is ay value. So the ay is 0, ax is minus 4. So therefore the ax, the total acceleration vector, it's ax I cap plus ay j cap. Ax I cap, ay j cap. So then which we write it as acceleration is equals to ax. What is ax guys here? Minus 4 I cap plus ay 0. So just ignore that term. So that acceleration is equals to minus 4 simply I cap. So they asked at time t is equals to 2 seconds, but there is no time term there, right? So no need to substitute. Therefore the magnitude of acceleration is simply minus 4 meter per second square. So minus 4 meter per second square. Option C. Clear? Understood everyone? Chalo, note this point. So then what is the another expression for instantaneous acceleration? So we have got, so the acceleration is equals to dv by dt. So till now we got acceleration is equals to dv by dt. So now what I am doing is the acceleration is equals to dv by dt. So this one I am multiplying it with dx and dx. So the numerator part and denominator part I am multiplying with dx and dx. So now, so let's rearrange the terms here. So let's write dx here, dv here. So dx by dt into, so let's write dv here. So dv by dx. So then the acceleration will be equals to, so the dx by dt is nothing but velocity. So the velocity times dv by dx. So the acceleration is equals to v into dv by dx. So acceleration is equals to v into dv by dx. So this is a one more expression for the acceleration. Previously we know that acceleration is equals to simply dv by dt. dv by dt. So now the acceleration is also equals to the v into dv by dx. So when to use this one? If velocity is given as a function of displacement, if velocity is given as a function of displacement, if velocity is given as a function of displacement, so then the acceleration will be equals to v into dv by dx. So we differentiate the velocity with respect to x and multiply it with the velocity. Clear? So I'll solve one question so that you'll understand better. See here. So let's go for this question guys here. So for motion of an object along the x-axis, the velocity v depends on the displacement. So velocity v depends on the displacement. Velocity is a function of displacement given here. See here. Velocity is a function of displacement, it is given. So then what is the acceleration at x equals to 2 meters? So velocity is not a function of time here, it's a function of displacement. So simply shall I write the acceleration function is equals to v into dv by dx, right? So when to use this formula? Whenever the velocity is a function of displacement, right? So then v, in place of v, we just write 3x square minus 2x into, so d by dx of velocity, so 3x square minus 2x. So then 3x square minus 2x into, so what is the d by dx of this one? So this differentiation is 6x minus 2. So then the acceleration comes out to be, so just multiply this part, or else just let's substitute the x equals to 2. So minus 2x into 6x minus 2. So then acceleration at at x equals to 2 meters we required. So in place of x, substitute 2. So here 3 into 4, 12 minus 2 into 2, 4. And then here also 6 into 2, 12 minus 2. So then 12 minus 4, 8 into, so 12 minus 2, 10. So which is 80 meter per second square. So which is 80 meter per second square. Clear guys? Understood the concept? Chalo. So that's it. We are going to wind up the today's lecture with this. So in the next session, we'll solve some more questions and we'll also understand the concepts of the reverse process. How do you get the velocity? Sorry, how do you get the displacement from the velocity, and how do you get the velocity from the acceleration? So that we'll understand in the next class. So till then, keep studying. All the very best guys. Bye. Take care.